Good morning to everyone. So today I am going to take the topic CPU scheduling. So what does mean by scheduling? Scheduling is a process which while executing the operating system will be allocating its work by using the priority. So here before going for scheduling, let us see the process states. So normally a process will be in 5 states, namely new, ready, running, waiting, and then termination. So your process, when it enters in execution, it starts from the new state to the ready. So it is admitted for the execution in the operating system. So next, from the ready state, if it is the current process which is to be executed, it will be transferred to the running state. So for execution it goes there. So suppose if it needs to be interrupted by any interruption, so there it goes to the wait. So by any IO device it may be, or IO event it may be, goes for the waiting state. So if the IO device event is completed, it goes again to the ready state. So after again from ready it goes to the running state, the concerned process. So from the running state, a process when it finishes its execution, it goes for the exit state, that is termination. So this is the 5 states of the process. So these 5 states only is used in CPU scheduling while scheduling a process to execute. So next we will see the scheduling basics. So here in the scheduling, the burst cycle is main important. Burst cycle is nothing but a event may be moving from the CPU to the IO device, or else the IO device to the CPU. So normally load a data, add data, store data. So a concerned data or a process may be loaded from the memory to the CPU. So that is only load data. Add data is nothing but any process like adding, incrementing the data, it will be done. Storing the data is after the completion of its execution, the data again will be stored in the memory. So this is CPU burst. Next we will go for IO. So after this completion, there will be IO burst. So here the process will be waiting for the IO device completion. So this is called as IO burst. Next again the cycle continues as load data, add increment, and then store data. So this is for the next process. So this is for process 1, process 2, like that the consecutive process will be taking. So here again the CPU burst, again wait for IO. So this is the IO burst. So like this the burst cycle is also mainly considered in the scheduling concepts. Next we'll go for scheduling criteria. So what are the main things, criteria which we'll be considering here is, normally a process, I told it will be transferring from one state to other state. So here the process transfers in 4 circumstances. So first one is, it switches from running to waiting state. Second one, it switches from running to ready state. Next, third, it switches from ready to waiting state. Fourth one, it terminates. So here in the scheduling, these 4 circumstances are considered by using the process states. So in these 2 processes, the first and fourth comes under the non-preemptive scheduling. Next, the second and third comes under preemptive scheduling. So these 4 circumstances are considered. So in the preemptive scheduling is nothing but, the preemptive scheduling is any one process may arrive in the intermediate, its arrival time will be considered. So when it preempts the ongoing process, by using the scheduling types, the process is allocated its jobs. So during the running to ready state or ready to waiting state, by any input IO device, the event is completed or it goes to the waiting. So here the IO device interrupts the current executing process in the CPU. So those both are coming under preemptive scheduling. Non-preemptive scheduling is a process once it enters for executing, until it completes its process, it will be ongoing, fully executed. Next is dispatcher and dispatch latency. So dispatcher is nothing but a CPU handovers its control to the process. CPU handovers its control to the process. So that is called dispatcher. Dispatch latency is the time it takes to respond when the CPU handovers the control to the process. So it is the time taken to save the state CPU to IO during the burst cycle. So that is the dispatch latency. So here in the dispatcher and dispatcher latency, the switchover between the CPU and the IO device will be taking place. So apart from this, what main criteria in the scheduling algorithms we are going to see is, first one is CPU utilization. Next one is throughput. Next one is waiting time, and next one is response time. So these are the four criteria which is considered. CPU utilization is normally a CPU how much maximum processes you can allocate and uses its resources, that is CPU utilization. So always the CPU utilization must be used in a maximum. And next is throughput. Throughput is the overall completion or time taken to finish a process. So here throughput also must be taken maximum. So it is the maximum completion of a process. Here it is maximum resources used. Next, waiting time. Waiting time is nothing but a process by any interruption it goes to the waiting state. So here the waiting time must be always minimum. Next is response time. So response time is a process once it enters the ready state, at first when it is gone to the execution state, that is ready to running. The first time before going to waiting, from ready to running, when it goes, that is called as response time, and the response time must also be in a minimum, it must be considered. So this is the scheduling criteria which we have considered. Next we are going to see the types of scheduling algorithms. So now one by one algorithms we are going to see and solve it with a problem. So the first type is FCFS, that is first come first serve scheduling algorithm. So this is the first type. So here in the first come first serve algorithm, the process will be, if it does not consider the arrival time, all the processes will be entering at the same time. If we consider in the problem by the arrival time, according to the arrival time it will be scheduled. In the FCFS algorithm, the first process which enters inside, it will be processed first. Next the second process will be scheduled next. So in this order it will be taken. Now we will be taking this example problem which is given here. So this is the problem which I have given. The processes are P1, P2, P3, P4 and P5, and the arrival time is 0, 1, 2, 3, 4 for each of the consecutive process I have taken, and the burst time is 10, 2, 3, 1 and 5 for the consecutive process I have taken. So here by considering the arrival time, now I am going to draw the Gantt chart for this problem. So the first step is we have to draw the Gantt chart. So this is a chart which is drawn the execution steps. So at the time of 0, process P1 enters. So here in the chart I am taking 0 as the first. So here process P1 enters. Next, after it travels 1 millisecond, if I see means the process P2 arrives. But when the process P2 arrives, if you see means by using the first come first serve, the first process which enters must have to complete its execution. So though P2 interrupts the P1, the P1 only will be continuing its execution due to the first come first serve. Next one is after this is first millisecond, and during the second millisecond if I see means process P3 will be arriving. So here also the same thing as P2 is considered. P3 will be interrupting P1, but by FCFS algorithm, P1 only will be continuing its execution. Next one is P4 arrives at the time of 3 milliseconds. So here when P4 arrives, so when comparing P4 and P1, P1 only will be continuing by the FCFS. Next one is P5 will be arriving at 4 milliseconds. So now all the process has arrived inside the scheduler, but P1 continues to execute since for FCFS algorithm used. So now P1 completes its execution at the time of 10 milliseconds. After P1 completes, next process which we have is the second arrived one is P2. So I am taking P2 into consideration. So what is the burst time of P2 is 2. So 10 plus 2 is 12. So after P2 completes, next one is P3 will be entering. So P3. So what is the burst time of P3 is 3. So now here 12 plus 3 is 15. The next process I have is P4. So P4 is, burst time of P4 is 1. So 15 plus 1 is 16. Next one is the last process which I have is P5. So the P5 burst time is 16 plus 5 is nothing but 21. So this is the chart available for FCFS. So first P1 will be executed, next P2, P3, P4 and P5. So these are the process. So now we are going to find the waiting time. So in the waiting time, if we consider means for process P1, it enters at the 0 milliseconds itself. So I am giving 0 minus arrival time. Here the formula is waiting time minus arrival time also we have to consider. So it is 0 minus arrival time of process P0 is 0. So the answer is 0. Next is P2. What is P2's waiting state? Waiting state P2 enters for execution at 10 milliseconds. So the waiting state of P2 is 10 minus arrival time of P2 is 1. So 10 minus 1 is 9 milliseconds. Next is P3. So when you consider P3, its waiting state is 12. Its arrival time is 2. 12 minus 2 is 10. Next is P4. P4's waiting time is 15 here. So 15 minus P4's arrival time is 3. 15 minus 3 is 12. Next P5. So for P5 its waiting time is 16 minus arrival time is 4. 16 minus 4 is 12. So now this is the waiting time found. Now we have to find the average waiting time. So what is the average waiting time? 0 plus 9 plus 10 plus 12 plus 12 divided by totally you have 5 process. So 5 is equal to, you have to add it. So it is 43 divided by 5. So when you divide it by 5, 43, you will be getting 8.40 divided by 5 is 8. So 8.6 milliseconds. So this is the average waiting time for FCFS. Next is turnaround time. So how will you find the turnaround time? Turnaround time is the overall execution time of a completion of a process. So here P1's completion is when it completes at 10 milliseconds it's complete. So it is 10 minus arrival time is 0. So here also you have to subtract the arrival time. So 10 minus 0 is 10. Next is P2. P2's completion time is 12. 12. Arrival time is 1. 12 minus 1 is 11. Next is P3. P3 is 15. Its completion is 50 minus arrival time is 2. So 30. P4 completion is 16 minus 4. Sorry, 3. So 16 minus 3, 30. Next is P5 21 minus 4. It is 16. So here the turnaround time is, when you consider the arrival time, if you subtract means you will be getting here. So now again you have to find the average of this one. So the average is 10 plus 11 plus 13 plus 16 divided by 5. So now if you add and divide it, you will be getting 12.6 milliseconds. The total value if you add. So this is the first come first serve algorithm. So next we will go for shortest job first, SJF. Next is shortest job first algorithm. Here in the shortest job first, the process which has the low burst time. The process which has the low burst time, that we will be taking and scheduling that process first. So that is here. So comparing to FCFS and SJF, in FCFS, suppose a process has more burst time, that is like example P1 has 10 and the other process has lesser than that. So the other process with lesser burst time must wait for a long time. So for that to overcome, next we are going for SJF. Here the process with the less burst time is taken first and executed. So here by taking the problem, we are going to draw the Gantt chart. So here by two methods in the SJF you can take. One is by preemptive method and another one is by non-preemptive method. So first we will go for non-preemptive method. Non-preemptive method means here you won't be considering the no arrival time. You won't be considering the arrival time here. So by that method, when you draw the diagram, the process which has the least burst time is P1 10, P2 is 2, P3 is 3, P4 is 1 and then P5 is 5. So the least one is P4. So I am taking P4 first. Its millisecond is 1. So at 1 millisecond it is completed. Next one I am going to take P2 since it has 2 burst time. So for P2, 1 plus 2 is 3. Next is P3 has 3 milliseconds. So P3, 3 plus 3 is 6. Next is P5. So P5 has 5 milliseconds. So 6 plus 5 is 11. Next one is P1. So P1 has 11 plus 10 is 21 milliseconds. So by using the non-preemptive method, without considering the arrival time, we have drawn the Gantt chart. Next here, how will we find the waiting time? So waiting time is without arrival time we are going to put it. So you no need to subtract here. So here what we are getting is for P1, its waiting time is 11. For P2, its waiting time is 1. For P3, its waiting time is 3. For P4, its waiting time is 0. P5, its waiting time is 6. So what will be the average? Average is 11 plus 1 plus 3 plus 0 plus 6 divided by 5. So here you will be getting the answer as 8 milliseconds when you add and divide. Next one is turnaround time. So the turnaround time will be for P1 where it completes 21 milliseconds, the time of completion. Next one is P2. P2 where it completes at 3 milliseconds. So it is 3. Next one is P3. P3 where it completes it at 6. And P4 is 1. And P5 is 11. So this is the turnaround time. Now the average is 21 plus 3 plus 6 plus 1 plus 11 divided by 5. So what will be the averages? 12.2 milliseconds. So this is the SJF method by using the non-preemptive method. So next we will be seeing the SJF method by using the preemptive method. Next, by considering the preemptive method, here the arrival time you have to consider. So, if you see in the chart means, first P1 enters for execution because at the 0 milliseconds only P1 arrives. Next, at 1 millisecond if you see means P2 arrives. So, when at the completion of 1 milliseconds if you see means when the P2 arrives, here its time will be 9. Its burst time will be 9 and the process P2's burst time will be 2. By comparing the burst time of 9 and 2, because in SJF we have to take the less burst time. So comparing the burst time of 9 and 2, we are taking P2 into consideration since it has less burst time. So here P1 goes to the waiting state in this step. So here I am taking the next process to execute is P2. Next at the second millisecond if you see means P3 arrives. So here 0 in the P2, here still one more completion it takes. So here at the second overall if you see means 2. So here when P3 arrives, what it does is its burst time is 3 whereas P2's burst time is now 1 less, so it is 1. When you compare 1 and 3, 1 is less burst time, so it will be continuing it with P2 itself. The P3 will be in waiting state. Next at 3rd millisecond, P4 arrives. So here at the 3rd millisecond, when P4 arrives, P4 burst time is 1 whereas P2's burst time is 2 minus 1, it completes. So 0 and 1 when you compare, 0 is it completes, 1 is it takes. So 1 is compared with previous 3 and previous 9. So when you compare these both waiting burst time, 1 is less. So here P4 comes into execution. You have to compare this P4 since P2 finished its execution with P1 and P3 process burst time. So here the P2, so 1 plus 2 is 3. Its completion time is 3. Next at the 4th millisecond if you see means P5 will be arriving. P5 is 5. So here if you see means since it is 1, here it is completed. P4's execution is completed. So after it completes, here the time is 4. Now if you see means the rest of the process left here are P1 is 9, P3 is 3 and P5 is 5. Now these all are in the scheduling. So here in the waiting state. So in the waiting state here which process has less burst time is 3 has less burst time. So you have to take 3 into consideration. So process P3 is executing here. So 4 plus 3 is 7. Next is process 5. 7 plus 5 is 12. Next is process 1. So 12 plus 9 is 21. So this is the chart of while using the preemptive scheduling. So here if you see means how we will be considering the waiting time. So waiting time P1. So P1's waiting time if you see means the last waiting time is considered as 12 minus previously already it has taken 1 millisecond for traveling. So that is you have to consider this minus 1 and minus its arrival time is 0. So it is 12 minus 1 minus 0. So it is 11. Next is P2. So P2's waiting time is 1 and its arrival time is 1. So 1 minus 1 is 0. P3's waiting time is 4 minus its arrival time is 2. 4 minus 2 is 2. Next is P4. P4's waiting time is 3. Arrival time is 3. So it is also 0. Next is P5. Waiting time is 7 minus arrival time is 4. It is 3. So now what will be the average? Average is 11 plus 0 plus 2 plus 0 plus 3 divided by 5. So its average is 3.2 milliseconds. Next one is the turnaround time. So turnaround time is for P1 where it completes 21 minus already it has travelled 1 millisecond. So minus 1 minus its arrival time 0. So 21 minus 1 is 20. So here it is 20. Next is P2. P2's completion time is 3. 3 minus what is its arrival time? 2. So here it is 1. Next P3's completion is 7. 7 minus its arrival time is 2. So it is 5. For P4 its completion is 4 and its arrival time is 3. 4 minus 3 is 1. Next for P5 its arrival time its execution completion time is 12. 12 minus 4 is 8. So what is the average? The average is 20 plus 1 plus 5 plus 1 plus 8 divided by 5. So you will be getting the answer 7.4 milliseconds. So this is the SPI of preemptive and non-preemptive scheduling. So preemptive means you have to consider the arrival time. Non-preemptive means you won't be considering the arrival time and the process which has the less burst time that you have to take and consider. Next concept is prior round robin scheduling. So in the round robin scheduling, here you will be fixing the time quantum. Here if the time quantum is large means the process must will be finishing its execution faster. If your time quantum is less means the process takes more cycles to execute. So here in this problem I am taking the quantum as 2 milliseconds. So here in the chart at 0 milliseconds the process P1 that I am considering it, and And next, what if you see means process P1 arrives. Next at P, what is its burst time is 10. So it takes overall only 2 milliseconds to execute. So the 2 milliseconds will be taken. The balance rest will be there after the cycle 1. Balance burst time will be noted. So that is P1 is 8. Next one is P2. After completion of 2 milliseconds, now P2 and P3 are in the scheduler. So we can take P2. So P2 is burst time is 2 milliseconds. So 2 plus 2 is 4. So P2 completes within 1 cycle. So there is no balance burst time in the P2. So it is taken. Next one is P3. So in P3 if you take means burst time plus 2 is 6. So 3 minus 2 is 1. So balance 1 I have in the burst time. Next one is P4. So in the cycle when you see means P4 is next plus 2 is 8. So it has 1 millisecond. So here it travels within the 1 itself. So here it is 7. So P4 is also no balance burst time left. It completes within a single cycle itself. Next one is P5. So P5 is plus 2 is 9. So here you have 5 minus 2 is balance 3 milliseconds I have still more to travel. So here if I take means again so this is after cycle 1. Next, still more when I continue, in the second cycle the process P1, P3 and P5 I will be taking. So again process P1 enters and it continues. So 9 plus 2 is 11. So now rest 8 minus 2 is 6 will be stored at the balance. Again it goes to the waiting state. Next process P3 is I have only 1. So 11 plus 1 is 12. So it completes its execution in the second cycle. Next is process P5 I take. So 12 plus here I have 3. So 12 plus 2 is 14. Here balance 1 I have. So this is after the second cycle of completion. Process P3 is completed. The rest of the process are in the waiting state. Next one is again in the third cycle now it goes. So now again process P1. So 14 plus 2 is 16. So here balance I have still 4. 6 minus 2. Next is process P3 is completed. P5 I have still more 1. So it is 17 I have. Next is process here after the third cycle P5 is also completed. So now again I can take for P1 alone. So P1 is plus 2 millisecond is 19. Next again 4 minus 2 is 2 and in the last cycle plus 2 is 21. So this is in the round robin by considering the time quantum the number of cycles will be repeated more until the burst time completed. So now how will we finding the waiting time? So waiting time is P1. So what is the waiting time? Last waiting time of P1 is 19. 19 minus previously how much time I have traversed P1? 2, 4, 5, 6, 7, 8. So totally 10 I will be taking. Okay. 19 minus 10 minus the arrival time also you have to consider. So 19 minus 10 minus 0. Here I will be having 9. Next one is P2. So this 10 is nothing but total number of P1 how much you have and into the time quantum. So P1 round into time quantum. So here it is 5 into 2. So it is 10. Next one is P2. So P2 is only once I have traveled. So its waiting time is 2 minus arrival time is 1. 2 minus 1 is 1. P3 is the last one is 11. So 11 minus 2. So 2 minus arrival time is 2. So 11 minus 4. 7. Next one is P4. So for P4 I have only 1, so it is 6. 6 minus arrival time is 3. 6 minus 3 is 3. Next for P5 I have at last 16 minus 2, 3, 4, 6. So minus the arrival time is 4. So 16 minus 10 is 6. So I have the now waiting time is 6. So now the average is what is 9 plus 1 plus 7 plus 3 plus 6 divided by 5. So the average is 6 milliseconds. So same wise as you consider for turnaround time, T1 will be, what is its last completion? So 21 minus its arrival time is 0. So it is 20. Next is P2 is, its completion is 4. So 4 minus arrival time 1 is 3. P3 is, its completion is 12. 12 minus arrival time 2 is 10. Next is P4. So for P4 where it completes 7. So 7 minus arrival time is 3 is equal to 4. Next is P5. P5 completion is 14. 14 minus 4 is 10. So now what will be its average? 20 plus 3 plus 10 plus 4 plus 10 divided by 5 equal to 10.2 milliseconds. So this is the round robin scheduling algorithm. So in the priority scheduling, what you will be considering is, by the same manner, the priority will be given for the processes. The process which has the highest priority will be considered and it will be taken for the execution. So the other which you have is multi-level queue scheduling and the multi-level feedback queue scheduling. So in this three scheduling is, if you see, means in this two scheduling, the process is divided into as level 1, level 2 as level 3. So like this, in the level order, the process is divided and the process at the level 1 is given the highest priority and the process at the lowest priority is at the last. So here what is the thing they consider is, always the execution will be from the highest process to the lowest process in each of the level. So without completion of the highest process, the lowest process cannot be executed. So due to this drawback, here what else occurs is, the starvation occurs. So this starvation is overcome in the multi-level feedback queue scheduling. So in this multi-level feedback queue scheduling, normally, example, if a process is considered as, normally round robin algorithm you are using, means it is considered as 8 milliseconds. So this is the highest level. So if it executes, if it completes, means the number of processes completed will goes to the exit state. If it does not complete, for the next level I am fixing time quantum is equal to 16 milliseconds. Its output which is not completed is given as a feedback to the next level. So here again, if it's completed, the completion it goes. Next, if you see, means again if it does not complete, it goes to the next algorithm, namely FCFS or SJF what we follow. So like this, in each of the level, in the multi-level feedback, the starvation is avoided by the completion process goes outside, exits outside. The other process exits, enters inside as a feedback for next process. So in all of these 5 algorithms, when we evaluate, the best process which we considered as a SJF algorithm will be considered as the best one. So these are the 6 types of the CPU scheduling method which we have seen now. Thank you.